in section 5.2 worksheet 1. So let's get that out and make sure that we have our lovely little formula sheet out with it so that we can make our substitutions faster. Yes? Okay? So, very first thing we have is number 1. What does number 1 say to do? Find the error in the identity below. Okay, the very first thing you need to understand is this is the problem. Okay? When you look at that problem, what do you see and what is your eye drawn to first?
Well, the negative x.
Your eye is going to be drawn to the lovely little cotangent of negative x, yes? So immediately you're going to go to your identity formula sheet. You're going to say, okay, cofunction, even and odd identities, are even and odd identities. What is the cotangent at negative x? What'd you say? Negative cotangent. So what that means is this is actually going to be negative cotangent of x. What did they put in place of it? They put a positive cotangent. So what did they do wrong with this problem already?
They put a positive instead of negative cotangent.
So the even and odd identities were not applied. So cotangent of negative x is equal to negative cotangent of x. So that is exactly the first problem that you would have had an issue with. And I promise you on the test, you are going to have a proof on there like this where you are going to have to find the error in the problem. Any questions over what I just said on that? Okay, next. Number 3. What do the directions say? Simplify each expression completely. It does not say that you have to have the left-hand side equal the right-hand side because there is no equal sign here. It is simply an expression. You have to use all of the identities as best to your ability to get this down to a nice little neat simplified package. So whenever you look at this thing, where is your eye drawn to? When you look at cosine squared of x, your eye should be drawn to the middle of this problem. And you should immediately say, hey, tan squared of x plus 1 is equal to secant squared of x. So if I take the 1 over to the other side, obviously this entire thing is going to turn into a tangent squared of x. So I have the cosine squared of x times the tangent squared of x. Then, the next thing that your brain should be thinking is, I have two different trig functions here, yes? So since I have two different trig functions, what should I do?
Get rid of one.
Well, how do I get rid of one?
You can
What is tangent squared?
cosine.
So I'm going to drop this cosine squared down of x, and I'm going to put tangent squared in terms of sine and cosine. So that's sine squared of x over cosine squared of x. And from there, what do you notice? The cosine squareds cancel out to give you a sine squared of x. Does that make sense, yes or no? We good? Okay, next. Number 7. Now, if you turn the paper over, number 7, the directions say prove each identity. When you have the word prove means that you are taking the left-hand side of the equation and you are manipulating that until you can make it equal to the right-hand side of the equation. Yes? So, what's the very first thing you think we should do here?
Negative cosine and 1 minus 1.
This right here and this right here. We need to apply our even and odd identities. The cosine at negative theta is going to be equal to what value? The cosine at negative theta is equal to what value? No.
Cosine.
Cosine. So this is the cosine of theta all over 1 plus. Now what is the sine at negative theta? The sine at negative theta
Is negative.
is going to be negative sine of theta. Yes? Okay, so from here, what do you think we should do? And we did a problem like this yesterday in class. Okay? We have two different trig functions.
Multiply
we are going to multiply by the denominator's conjugate. The denominator's conjugate is going to be what?
1 plus the sine of theta.
Yup. 1 plus the sine of theta. What should you do to the bottom? You do to the top. Put parentheses around everything. And now what do you think you're going to do? FOIL the bottom. So the cosine of theta times 1 plus the sine of theta is equal to 1 minus the sine squared of theta. What is 1 minus the sine squared of theta equivalent to? So I'm going to take this right here and I'm going to say, hey, that is one of my Pythagorean identities. So I recopy the top and I'm going to sub in cosine squared of theta. Yes? Now what? What do we have in the top and the bottom?
Cosine.
I have a cosine to the first up top and a cosine squared on the bottom. The cosine to the first goes away and the cosine squared turns into just a cosine. So now I'm left with 1 plus the sine of theta all over the cosine of theta.
Then you split those into two different fractions.
Now we want to write these as two separate fractions with both of them having the denominator of cosine. So this is 1 over the cosine of theta plus the sine of theta over the cosine of theta. And what is 1 over cosine?
1 over cosine secant.
And what is sine over cosine? So the question is did we prove that the left-hand side is equal to the right-hand side of secant of theta plus the tangent of theta? Does that make sense, yay or nay? Are we good? Okay, now, the last one that we have going on here is problem number 12 that I'm going to talk about. This looks nasty. And the reason why this looks nasty is because we have cosines with two different angles. X represents one angle, Y represents another angle. And you have to treat them as different angles in your head. So you cannot drop the X and the Y and keep them all as one X or all as one Y. You have to keep the letters just as you see. Okay? So you have two fractions attached by addition. So when you have two fractions attached by addition, what must we find first? The LCD. What is the LCD between this denominator and this denominator?
Sine of x plus sine of y. And cosine of x plus cosine of y.
When it looks ugly like this, you are simply going to multiply the denominators together. Yes? So what I'm going to have here is one fraction with this denominator. Yes? Okay, are we ready? Now, I am going to drop down the current numerator because regardless, I have to have it. Now, what did I tack on right here to that sine x plus sine y to get the current LCD? What did I tack on to that? Yes? Okay. Then, I'm going to go ahead and have black, and I'm going to write down what is currently in the numerator already. And then what did I tack on to the second one over here?
Sine x plus sine y.
So that is going to be sine of x plus the sine of y. Okay, what do you notice about the numerator right here?
Conjugates.
They are conjugates. So if I FOIL those conjugates, all I have to do is first and last. So that's going to be cosine squared of x minus the cosine squared of y. What do you notice about these over here? They are as well conjugates. So since those are conjugates, I'm going to go ahead and FOIL those. getting plus sine squared of x minus the sine squared of y. And all of that is going to be over this ugly denominator. Yes? Do we all see it? Are we all good? Okay. Next, I want you to look for the x's. So this is a cosine squared, and this is a sine squared that's positive. What does cosine squared x and sine squared x equal?
1.
So cosine squared x and sine squared of x, and I'm just going to rewrite this so that you see them. And then this is going to be negative cosine squared of y minus sine squared of y, all over that entire denominator. Okay, this right here you guys said is going to be 1. Yes? What's in common between these two terms right here?
The 2y.
Look again.
Squared y. They're both negative, they're both squared, they both have a y.
So if I look at this right here, and actually I'm going to erase this. I'm going to erase this. That is our regular identity. Would you agree? What if I were to multiply this entire thing by -1? Then that would be negative cosine squared of x minus the sine squared of x is equal to -1. Do you see that? So when you see that the cosine and the sine are both squared and they are both negative, what is the outcome that that's going to equal? -1. So we're going to go all the way down here and we're going to say, hey, this right here is going to be -1. So now I have 1 plus -1 over this junk. What is 1 plus -1? What's 0 divided by anything? So the answer is 0 then. Your homework is to complete the rest of the worksheet. You will see in Classroom that I've already posted the answer key and I've posted steps on how to get the answer. I did not post my work. I walked you through what you should have done. For example, apply the LCD. Multiply by what you need to get the LCD. FOIL. Combine like terms. Use the trig identities to cancel out and use the Pythagorean identities. And then cancel out. Okay, those are the steps I would have said on Google Classroom. Yes? Tonight's homework is to finish section 5.2. I'm going to be grading sections 5.1, bookwork 1, 2, and 3 now. Okay? I am done.